tutorials today, and go ahead and get started. So when you first get your HP50g, turn it on, see this kind of blank screen, and you see this enunciators up here and a menu down here. First thing we're going to be doing is kind of changing some things around. This series, or this video, is aimed at people who kind of already know what to do with the stack. If you have general questions about the calculator, the quick start guide that comes with your calculator when you buy it is a great resource. There's many other resources online, so it's best to use those if you don't really have a clue about what to do. But I'm just going to go ahead and kind of configure the calculator in the way that we're going to be using it. So when you first get it, it looks like this. It has this ALG up here. And the first thing is that this ALG needs to go away. Right now you can do 2 plus 2 and we get 4. And this is really great, but to be able to program the calculator and to really unlock the full functionality thereof, we need to get it into RPN mode, because that's the mode that really lets you go kind of low level with it, unless you work with the functions in the most effective possible way. So we'll go ahead and press H for mode, and simply just going to push plus and minus, or the change sign key, and we have RPM right here. And this is probably the most important shift, but there are many little shifts we need to make just to kind of get it to where we need it. But it needs to be in RPM mode. You can't really use the calculator the proper way if you don't have it in RPM mode, even if you're just doing normal operation, much less for programming. So the next thing we're going to do is we're going to go ahead and go into the flags menu. The flags menu is extremely important. In this, you can find pretty much all the system settings, and there's a lot of stuff in here, and I suggest you go through these on your own and just kind of, there's so many little preferences and things you might have. Just go through and make your calculator your own. This is really just every single setting that really is possible is included in here. So it's just really cool if you can go through and kind of make it your own. There's a few things we need to look at together, and I'm going to try to accomplish this pretty quickly. I tend to change this. I don't really want, if I get an infinite answer, I really don't want it to throw an error and stop a program or something if I'm in the middle of using it. So, because an error will halt any current processes and things like that. It will cancel them. So I don't really want that to happen, and I'd rather just deal with this. We get like a very large number with the 9E499, the maximum possible number. We'll get that instead. That's nice. So, and there are many of the stuff you just gotta go through and look at it yourself. Stuff is interesting. Clocks, and what format you show the dates in. I mean, a lot of different stuff. It's all very pretty cool. Here's something else I'm going to change. This alpha locks. So what this is that if you press alpha once, it lets you type one key as a letter, and then it goes back to the number mode. It'll cancel the alpha mode. And if you press alpha twice, then you can type a number of characters, and you'll get a lot of letters and different things. And then you can press alpha again, and it cancels that mode. But for programming, and I just like to have this for how I use it, I like to be able to just press it once and then type as many letters as I need to, and press it again and have it be canceled. And in fact, it actually confuses me when I don't use it this way, because I'm so used to having it, and so I start typing things, and when the functions and stuff start to come up and numbers and things, I'm like kind of going, what's going on? So we go ahead and change this. We'll have only a single alpha lock alpha. You have like custom keys, settings, and stuff. Pretty nice. You can even have like an analog clock if you want to. I don't really need a clock. I have a cell phone, and clock on my computer and different things that I can just use, but pretty cool stuff. I also like to have left stack display. I don't really know why. I think that it's useful for, it just keeps all the instead of having your results over here on this side, your results come over on the left side of the stack, and that's pretty nice. I just like it because it seems to make it interface a little easier to use. There's really not that much that I need you to change, but I'm just kind of going through just so you can see kind of the different settings and things you can do with the calculator. This is very important. It's flag 117. So, for instance, right now, if you have this unset and you go into the algebraic menu or the trig menu or any of these menus down here, it'll pull up a little dialog box, and you can scroll up and down and choose what thing you want to do from those menus. And that's nice because it's very graphical. It's easy to understand what's going on. But once you press it, the dialog box goes away, and you have to come down here and press the menu again. And that's not very useful because it means you have to go and press and get the menu up every single time you want to use just one function. If we set this flag, you get this soft menu. And that means that when you open a menu, it instead appears using these keys right down here, these function keys or soft menu keys as they're called. And you can use next or previous to scroll through the pages of, and of course there's no other pages in this list right here, or on this menu right here. It's just check, cancel, OK. But you can actually just use that. It means you can keep on using the menu even after you've used, even after you've done something with it. And so it's very useful to have that because it does not take up your entire screen. You can see what's going on, and you can also use the functions over and over again. And so that's pretty much it for the flags. I suggest you go through on your own and just, check these as you want and make sure your calculator is going to work how you want it to work. So make sure to press OK. If you just press on, the settings won't change. They won't save, and the calculator still work like it did before. And somehow I managed to get this to not. There we go. All right, so go ahead and clear off the stack. So now we're in RPN mode, and if you don't know how to use RPN mode, it's there's a little bit of a learning curve to it. But instead of actually seeing any operations, you have to enter the values you want to work with on the stack and then manipulate them with the operations. If you want to have some information about this, there's other videos and other things that I really don't want to spend time with on this video. So we go ahead and advance to our next objective, which is the file system. The HP has a pretty nice file system. It is compatible with Windows. I believe it's either FAT16 or FAT32. I can't remember, but it's something that's able to work with Windows. So when you have an SD card in the bottom of the calculator, which I certainly don't here, but if you have one of those, then you can actually put that in and transfer files directly with your computer, and it's a very useful capability. But if you press var, you can actually see the variables or files in the current directory. And what you can see up here, this in the enunciator, this little thing surrounded by brackets is your current directory that you're in. So right now we're just in home, and home is the partition within the RAM of the calculator where the things you directly work with are stored. So if I say, okay, well this number is important. I have an 8 here, and you put 2 tick marks, and you say, okay, this number is going to be called X. You enter, and then you press stow, and that means you have this 8 stored, and it's directly stored to this home directory. And we can go see this directory if we push left shift apps files, and we go to home. And you see there's two things in our directory: the caster, which is a system directory, which has a number of important things in it for the computer algebraic system. If you delete it, it'll just come back. So no real point. It doesn't say the much room anyway. It's only 117 bytes. And then we have our X, which if you look at it, it simply has an 8 in it. This information over here and these little pictures, they're pretty cool. You can see the caster is a directory. It has the little image of a folder, and this has one of those R's with the double bar on it or a line on it, so you can tell that it's a integer or a real number. It's just pretty useful for seeing what kind of files you have. You can copy files, move files. If you go over to this tree, you can see you have a list of all the different memories and things you have in here. This IRAM and home, you can see they have the same amount of size right here, 239 kilobytes. These are actually the same as IRAM and home, but if you press IRAM, you go into IRAM, there's no entries. And that is because IRAM is what the calculator directly works with on the stack, whereas home is where the user stores the variables in the same space within memory, but it's just reckoned with differently by the calculator. ERAM is, I believe that's some sort of another partition for the calculator work with, kind of like high memory. I'm not sure exactly. And then flash. This is very important. Flash memory is like your ROM or read-only memory. It's kind of like a hard drive. If you have an SD card stored, it shows up as port 3. You have 0, 1, 2, and the SD card would show up right between flash and home. It'll be port 3, and you can store things in it, treat it like any other thing else. The only thing you can access with the soft menu here by pressing vars is home and subdirectories within home. So if I go into the caster directory, you can tell it's a directory, but it has a little folder kind of look to it with a little tab up there. Then you can see that the enunciator changes, and we have home caster, and then there's the things that are within the cast directory. And I suggest you find out what those are and experiment with those in your own time. Very cool stuff. So in home, we just have where the user, kind of the area for the user to store things. You can put stuff in Flash, but you cannot operate directly on Flash, and you cannot edit Flash directly. You have to load it to RAM somehow, either to the stack or copy the whole variable into the soft menu, edit that, and then save it back to Flash. And it's the same way with you have an SD card. So the only thing you can work with directly is if you move something into RAM and then edit on it, and yes, it just works like a computer basically, except that except you're the one who's going to be working on it with RAM. You decide what to do with it. The program doesn't. So it's a very stripped down kind of operating system. But one of the first things that I always like to do is I don't want to clutter up this home directory. I like to have different folders for different things. So I'm going to go ahead and make a new directory. And so you press new, it says new variable up here, and you can either make a new variable or a new file, or you can just go ahead and check this for a directory, and you can see the object or the contents that you might enter what goes away. And we'll press alpha, and we'll call this Davis because my name is Davis. Press enter twice, and there it is. It appears right there. We'll go ahead and, just for some more operation, we'll go ahead and move this X variable into the Davis folder. Just press move, go down to Davis, enter, and now it's gone. It's in Davis. So back out of that, and here we are, home Davis, and we have the X file right there. And that was just a little intro in the file system. It's very useful, very versatile. Explore it more. Definitely worth looking at. All right, so with that said, I'm going to go ahead and kind of end hopefully the boring part of the video is now over, and I'll go ahead and talk about programming a little bit. Now, I can go on and on about programming, and I just want to make this intro to it. Very simple, very simplistic. And I'm not going to explain exactly how the entirety of programs works. I just want to make this kind of an introduction to it, the idea of how programs kind of work when they're run. And I kind of just want to make it simple. So for this example that I'm going to about to do, the program kind of acts like a macro because it just does what you would do if you were controlling the stack. So the calculator is just doing functions to the stack just like you would. And so it's like instead of having you press all these operations in a row, you decide, okay, well, I want to save these operations and I want to do them over and over again. And you just say, I'm just going to put these operations in a file. I'll save them a certain way, and the calculator will do them back for me. So you don't have to remember or key through all the operations. So it's kind of just like a macro in some ways. And the first thing we're going to do is to make a program, you have to use these special brackets right here, and they actually have a name, and I don't remember the name. I'm going to go ahead and enter the input pair of brackets onto the stack because I want to show you how it appears in the file system. Press alpha, and this program is going to be called PYTHG. You might be able to guess by the name what it's going to be, but PYTHG, and I'll store it. Store it, and you can see it appears down there in the soft menu because we're in Home Davis and I stored it in there. Yeah, so store stores in the current directory of home. Now, when you look at this, it has this big black blob. Big black blob is kind of a mouthful next to it, and it has PROG. So it's a program, and it's identified just by these special kind of brackets over here. And I'm not really sure why they chose a big black blob to use as the picture, but it's certainly recognizable, and that's what they set it on using it. I don't really mind it. It just helps to identify it. So, and you can move it like any other file. It's just a file and just happens to have a certain way of presentation. Now you can actually go and edit files directly through the file manager, but I like to edit it on the stack. So if you press right shift, then A. Now, if of course you simply copy the object onto the stack, regardless, because it's a program. If we just run it, now this program right now doesn't do anything. If we just run it, it won't do anything. So if you want to copy the object on the stack, which this does if you just press it, but if you have a program or something like that and you need to copy it on the stack, you just use right shift. You just use right shift and then you press the corresponding button with the soft menu to get it on the stack. And to edit something from the stack, you just press the down arrow key. I'm going to go ahead and enter. So what do we want to do with this program? We want to do the Pythagorean theorem, and this is something that's pretty simple. I'm just going to kind of do it just for proof of concept in some ways. The first thing you're going to do is you're not going to write anything in the program. So let's get back out of this, and you're going to think about what do you do normally if you want to if you have two numbers and you want to find the hypotenuse if those were legs of a right triangle. So let's say we have 3 and 4. Those are on the stack now. So 3 and 4. When you have the Pythagorean theorem and you want to find the hypotenuse, you need to square the two leg sizes, the two leg lengths, and then you need to add them together and then take the square root of them. So the first thing you're going to do is you would press squared, okay, and then because the other value, you also need to square this value, you have to swap. And you simply do that by pressing the right arrow key, the value. So the 3 is on the bottom, the 16 is up there. You do the same thing again, you add them together, and then finally you take the square root. And so those functions are the same ones this program is going to do in that order. It's simply just a macro for all those keys that you had to painstakingly press. Yes, I know it was so hard to press those 5 or 6 or 7 functions. And so it's just kind of like you simply have to remember what you did and copy it to this program. So the first thing we did, because we had 3 and 4, I'll go ahead and write them over here, 3 up here, and 4 down here. Those are our leg lengths. And the first thing we need to do is we need to square the bottom value, SQ. And if you press a function, you do plus or minus or change sign, the functions don't actually do anything because of this PRG input enunciator up here is shown. It lets you, if you press a function, simply copy what the function is into the program. So these are how these things appear. If you want to have a squared function or the square function, you simply type SQ, and so you can simply, all you have to do is just press the same keys, and the calculator knows what to do. It puts the image of the key into the program for you. It's great. And so the next thing we have to do is we squared it, so now I have 16 on the bottom, and next thing we need to do is swap the values. We need to somehow get 16 up here and 3 down here. Now, if you press the right arrow key in the edit mode, then of course you just move the right arrow key. So how do you swap the value? Well, it's pretty simple. You just have to type swap. And now 3 is on the bottom, so we have to square the value. We have 9. Next thing we do is we add the values together. That makes 25, and this top level is clear, or it has the thing that was above this on it. Add the values together, and finally we take the square root of them. And that's it, because after this key sequence, you now have a 5 on the bottom, and at that's the end of the program, because I mean that's all you need to do. And that's as simple as that. You just put these key sequences into a program, you copy them into memory. Here it is. We have this object on the stack now, and to save it, we just do left shift and then PYTHG, and now it's saved. So as a test, put 3 and 4. You just use it just like a normal function. You can type it in and have it work like that, or you can simply just press the corresponding key, and there you go, wham, 5. And of course, if you do 6 and 8, you get 10. So it's a great way, just a great little demonstration program to show how the HP uses key sequences to do a very macro-like program structure. And there's really much more to it, and so I kind of want to get to this later, but I think this video has been very kind of informational, just an introduction, very important for that configuration stuff. I suggest you look or kind of just experiment with the configuration of the calculator, and look forward to perhaps another video about programming and starting to get a little more in-depth on what programming really is in the HP50g. Thanks, and I hope this has been helpful.